Yeah, good morning, folks. This is Juergen again from CSAT. I'm still a little bit under the weather, and my last block was about flu and flu vaccines. This is what we do here in my research group at Kansas State. And today I want to discuss a little bit about another agent, another pathogen we work with, which is called Rift Valley fever virus. It's a different virus from influenza. It's a Bunya virus. It's also segmented, also an RNA virus, so it can reassort, and it's an RNA virus. So in many cases they have a very, very efficient molecular evolution, but that's not true for Rift Valley fever virus. Rift Valley fever virus is rather stable in the field. It infects humans, and in humans it causes about 1 to 2% mortality, and in recent cases up to 20%, so it somehow gets more virulent. And it's transmitted by mosquitoes, mainly Aedes and Culex mosquitoes, which are present in this country, not only in the endemic regions, which is Africa and the Arabian Peninsula. And it infects mainly ruminants. Here the sheep, goats, cattle, and some wildlife like deer most likely, and also camels might be affected by Rift Valley fever virus. And again, it's a vector-borne disease, and the vectors, these susceptible vectors, competent vectors, are even in the US. Was first discovered in the 1930s in the Rift Valley in Kenya, East Africa, and since then it's spread all over Africa, West Africa, North Africa, South Africa, Madagascar, and in the 2000s it made its jump into the Arabian Peninsula, into Yemen, Saudi Arabia. The big questions here are diagnostics and vaccines. There is no licensed vaccine for humans in the market. In Africa, there are several vaccines people are using, and they are mainly modified live virus vaccines, where they use a virus attenuated, make it less virulent. And then, if it's less virulent in their animal models, they use it to vaccinate cattle, sheep, and goats, etc. And this is a very good way to vaccinate animals. The problem is, it still might revert to virulence, which we have seen with some viruses. And secondly, it doesn't have DIVA compatibility. And DIVA has nothing to do with Oprah, with Maria Callas, and Deborah Vogt. It is differentiating infected from vaccinated animals, DIVA. Very critical tool for controlling of infectious diseases, because if you can differentiate a real wild-type infected animal from a vaccinated animal, it's much easier to control and eradicating a disease. And these modified live vaccines, which are used in Africa, do not have this DIVA compatibility, and even the new ones they are developing, CDC and other people in this country are developing modified live vaccines where they delete certain genes from the genome, virulence genes like the NSS and NSM. It's still not as good DIVA compatible as one want to have. So we at CSAT went on 4 years ago and developed a subunit recombinant vaccine based on the two glycoproteins, the GN and the GC. We express it in baculovirus and use it with an adjuvant to immunize sheep and cattle. Has very nice immunogenicity, and if we challenge these animals with virulent Rift Valley fever virus challenge material, they are protected. So what we are doing this year, 2017, we have done all these proof of concept experiments. We work with a company, we licensed the technology to a company called Medgene, and this year we are doing the definite experiments for licensure at USDA CVB. CVB stands for CVB stands for Center of Veterinary Biologics. These are the authorities to license vaccines and diagnostics for animal use in this country, in the US. And this year we hopefully get our license for our subunit Rift Valley fever vaccine. And I think this vaccine is DIVA compatible. It's safe, efficacious, can be produced in a very efficient way in baculovirus, and is protective after 2 shots. You need a first shot and then booster, and we are working on to figure out whether it's even protective after 1 shot immunization. Thanks a lot for listening in. Bye.